Okay, welcome back to this teach out on augmented reality. I have brought in members of my research team here at the University of Michigan. I'm an assistant professor in the School of Information. My name is Michael Nebeling. Say who you are.
Hi, I'm Maximilian Speicher, but I usually go by Max. I'm a postdoc in Michael's lab, working on augmented reality topics, mainly concerned with prototyping, and before that I was working for an augmented reality startup for 2 years.
Very good. And I'm Brian Hall. I am a doctoral student here at the School of Information in Michael's lab, working in areas of augmented and mixed reality.
Okay, so I would like to structure our conversation around the what is good and what is bad. I mean, we have quite a lot of experience with these augmented reality technologies, and so the idea is that we'll tell our viewers a little bit more what it's like to work with these devices and where do we see the limitations. So I want to start with maybe Max. So when was the first time you actually tried out an augmented reality experience, and what was your initial reaction?
I was underwhelmed. It was 3 years ago. It was on a smartphone. It just wasn't very stable. So the 3D model jumped around in strange ways. It just didn't feel very sophisticated.
So you were holding your smartphone and viewing some interactive content, and you felt like it didn't feel natural.
It was supposed to stick to a physical object like the table, but it didn't really work out.
Okay, so let me just follow up quickly on that one before we talk to you, Brian. So then, what is it like now? Has it improved? Is it still the same state of the art?
It has clearly improved. So a lot has happened in these 3 years. The tracking, like attaching a model to physical objects, it's much more stable now. But we're not totally there yet.
Okay, so there are still some limitations with smartphone AR. We talked about the recent developments around AR Core, ARKit, and software-based augmented reality on smartphones. Okay, so I would agree that it's still not fully there yet, but we're seeing a lot of technological improvements. Brian, let's just ask you the same question. So when you tried out AR for the first time, what was the application that you tried out, and how was the experience?
Yeah, sure. So I'd say I think where it sort of started when I heard about it was sort of seeing some of the proof of concept, sort of early videos of showing these digital objects in the real world. And I thought, well, that might be interesting for research I was sort of brewing up at the time on drone interfaces and for commercial drone usage. And I thought, well, that might be an interesting use, so I was able to get a hand on some of them and worked on them, like tablet-based interfaces, where you had like a live camera feed and then you had a sort of a heads-up display on top of it. And I was surprised by just how very limited it was. It was really just maybe a dot or two, maybe a few levels, a little piece of text in the bottom, and that was it. So I thought, wow, there's a lot of potential there. There's a lot we could do, but what we have right now, there was almost nothing to it.
Yeah. So when I hear you guys, there's a little bit of, I can hear the experts. We are still, I think when I tried it out my first time, I was like, wow, this is actually great. But I feel the more time I spend with it, the more I saw the limitations. And when I hear you talk about it, I think we hear a lot about these limitations. So speaking of limitations, what do you think are, I mean, you have spent more time with these devices now. We develop a lot of interfaces in my lab. What do you think is one of the biggest limitations that if we addressed it, if we somehow overcome it, it would actually make these experiences better?
It's hardware mainly. So sophisticated augmented reality apps need a lot of processing power. So if you want to really do it on a smartphone, which is awesome that it works on a smartphone, but if you have really elaborate apps, it drains the battery. The devices easily overheat. So for like average everyday devices, you have to keep the apps pretty simple.
Yeah. What do you see as the main limitation, Brian?
Yeah, so I would say that one I was surprised is that I wouldn't say that there's a single bottleneck. I was actually surprised in how many different areas that we need to have advancement in. So whether it be from the optics of what you're seeing to the, of course, to the hardware, like Max said, with the just trying to do basic things pushes the limit. To even so, like the most recent one I was dealing with was actually programming language design. That traditional programming languages have generally been written left to right, top down, like we have written language. And to do effective work in the sort of high demand, complex environment of an augmented reality headset, you need to start things so like parallel programming and things like that, where suddenly you don't know what order things are being done in, and reading left to right, top to down is not really how anything works, and how it can't work. And that really calls for a very different way of thinking about even just how to accomplish seemingly basic things that shouldn't be hard in your mind. And it turns out it's actually pretty hard to accomplish in a way that's going to be performant and satisfying.
Okay. To give a little bit more context to our viewers, so many of them may have seen promotional videos. They may have seen, wow, this is what you can do with this device, this is what you can do with that device, and it always looks like really, really great. So I know that we have a lot of these discussions in our lab around the promotional, the way it's portrayed, the experience versus the actual experience. So if you take your favorite device and you compare a little bit what it really feels like as opposed to how it's advertised.
My favorite device is the HoloLens. So while my first encounter with augmented reality was pretty underwhelming, I had this wow effect with the HoloLens when I first tried Roboraid on the HoloLens, where you have to shoot and evade alien robots, and that pretty much looked like the promotional video that was provided by Microsoft. So that was really the moment where I felt like, wow, this is pretty much like in the video. So,
okay, so
it already comes pretty close. There are limitations like the field of view. So the videos are still clearly a little engineered, but it comes kind of close, I'd say, definitely.
Yeah. So Brian, if you want to follow up, pick a device and compare what you've learned before you had the device, and then what it was actually to work with these devices. Yeah,
so starting off with just the very basic tablet-based interfaces that I saw initially, that I thought that's what augmented reality sort of was. They were so limited that I thought, wow, this is this cool technology, and no one is doing anything even vaguely useful in it, and it's not very interesting. And it wasn't for a good year or two later that I saw the HoloLens, actually. And that was the one that I did have that wow factor. And I think it was something as simple as where you pull this little hologram out and there's like a ballerina on the table or something. And it was this idea that you could point to something as if it were sitting here, but it's obviously not there. So it's this complexity of going, well, it's there, but it's not there. It looks like it's there, almost like a controlled hallucination. And I thought, well, that's amazing, and that's really cool stuff.
So you would say it actually reaches the stage where you have to remind yourself that it's not real because it seems so real? Or, I mean, it was a ballerina after all.
Exactly. It's like you can reason about it that clearly it is not there. And it does have this, so what you don't see in the video is that it's kind of ghostly. So it's more like a Hollywood special effect that you can kind of see through it because it's not fully opaque. So you know mentally it's not there, and you can tell that it's different from the environment. But it's sufficiently compelling that so like one thing I found is if you sit at something there, like in the middle of a pathway instead of a table, you don't naturally want to walk through it. You actually want to you want to walk around it as if it was a physical object, because you already kind of believe, like, yeah, no, it must be there, without really thinking it through. So yeah, it's compelling enough.
Okay. So these are, to be fair, quite different experiences, smartphone versus wearable, and they each have their pros and cons. So let me ask you, like you said, there are not so many compelling applications. So if you, again, pick a device, and then what is a compelling application for that device?
Well, Roboraid for the HoloLens, clearly, because it looks good, it's pretty stable, and you really feel the game. On mobile devices like tablets and smartphones, I feel like ARKit and ARCore are doing a pretty good job, although this is still mostly tutorial stuff and very basic. So it looks very good, the models look good, but it's still more of a playground.
Yeah, as developers, we often talk about these things as toy applications. It reminds us of previous technologies like tabletops, where essentially you could move pictures around on a surface, on a digital surface, and it seemed like for a while this is all you can do. And I feel personally a little bit about we're not really, like, I'm curious actually what is the next step. I mean, we're seeing more AR applications on smartphones, we see more AR applications on HoloLens. So and we have, of course, other devices like mixed reality headsets. There are a lot of competitors in the space. So without maybe going a little bit away from specific devices, let us talk a little bit about what you think could be future improvements so that we could have these better experiences. Does it need a completely new device, or is it that specific aspects of a device have to be improved?
I think augmented reality glasses will become a thing if we can bring them down to a size like this and really ensure that there's enough processing power, or the applications are efficient enough so that it really doesn't overheat and shut itself down, and that it really looks like normal glasses. I think that would be that would facilitate quite some killer applications that you can actually also use in the real world, versus having all these toy applications on smartphones.
Yeah.
Right
so
now.
when you say that, so some viewers might think of, oh wow, I mean there was Google Glass, and what was the problem with Google Glass, which was essentially a heads-up, wearable, some would say augmented reality display. Others would probably not say it's augmented reality because it does not actually react to the physical world. It doesn't actually overlay, and it doesn't have these anchor kind of ideas. So what needs your new glasses? How do they have to be different?
Well, I mean, Google Glass basically showed you some lines of text in your peripheral field of view, and so Google Glass couldn't do 3D models. I mean, Google Glass wasn't really glasses. It was more like this little extension that you had up here. It didn't react to the environment, as you said. So having a system or a device that can really react to the environment and then display the necessary content in 3D rather than just flat text, that makes a difference.
That way. Okay. And Brian, what would you say? What's your, if you had $1 million, what would be the device that you would be building to improve future applications?
Yeah, and I think actually that sort of kind of goes even back to what you sort of said, like the difference in the marketing versus, so the initial videos versus what we have now, is I think, Google Glass was, I think, a great testimony to the idea that just getting an idea of what's possible really causes your imagination to kind of run away with you. You go, wow, what if I could do this? What if I could do that? And there's all these interesting things that sort of pop up as, oh, what can we explore? What can we do next? And to me, it sort of reminds me generally of this idea, like if you've ever been to like a new housing development where they just put in the streets and they just paved everything, and it's all really nice and this beautiful blacktop that's so pristine. And then you get this new idea and you just turn off the main road off to this little side road, and all of a sudden it's gravel and rock and dirt and nothing is ready yet. And to me, that's sort of like what happens as soon as you try to do something different that's outside of the narrow context of what's already there, is that actually, wow, all of these applications you could use, there's a lot of areas that it's not ready there yet, and it's actually everything has to be developed. So personally, I'm a little less concerned with the idea that everyone's going to immediately have a device that they want to wear that replaces glasses, that replaces a smartphone, because I think that's a bar it's very high, but also I think that maybe overlooks some of the specialty uses of it. Like we have laptops that we don't carry around with us every day, but they have great usage. So I think that was one of the most compelling uses of like the Meta headset, the HoloLens itself that looks at.
So both of you seem to be arguing for some kind of wearable, something seamless. Hardware needs to be more portable, smaller, still yet more powerful than what we have. So what would you say? When will we be there? Is it like 5 years, 10 years? What would be our prognosis as some of the experts working on some of these technologies? What would you say?
5 years, probably not. I wouldn't think that. I'm pretty sure we'll be there in 10 years. And I also think in 10 years we'll be at the point where everybody can create augmented reality experiences just like everybody can create websites nowadays.
Yeah, it's a whole point that, of course, in our lab we talk a lot about making it easier to create those interfaces and new kinds of programming environments, tools that we need. So what is your prognosis, Brian?
Yeah, I'd say it's funny actually sort of looking at this space initially, because I thought, well, this is sort of new and how interesting. And then as I've learned a little more about it, I thought, well, shoot, I'm already too late. Like here within 6 months to a year, they'll already have everything that's really interesting, and sort of like I missed the wave. And now the more I've looked into it, the more I think, No, like we've gotten finally to the point that we can start to investigate what are some really useful, human useful applications of this new sort of technology that we've stabilized enough to make it
in fact,
a little bit. But
yeah,
but we're not. But I'm surprised at how far away the sort of the practicality of it is. So I think within a year or less, we'll start having niche uses that are useful in certain areas, in the same way that we already have a few that are sort of probably hiding in areas that we haven't seen. As for mass market acceptance, where it just becomes a daily thing for everyone, I mean, maybe 5 or 10 years, but I think I almost picked that time period because that's far enough away that I don't feel like you'll hold me personally responsible if I'm wrong.
I will. 10 years is a lot of time. I mean,
exactly. And what's going to happen in 10 years? So it almost feels like, in the year 3000. So, because it beats me, really. Like I think it's partly because I think it's not fate. I think it's a question of what we invest in it.
Although it is interesting. I mean, if you go back, I mean, these devices are essentially not new. What is new is that they are now becoming consumer devices that you can buy them. The research actually goes back 20 years. So I'm not sure what people were saying, how they would have answered that question. So we need to be careful. 10 years seems like a lot of time, but there's a chance that we're not improving into the right directions, that we're not really thinking about the right kinds of devices that we need. And we may just have actually just in optics in itself, which I think is a topic that we are actually not really working on. There are so many challenges there that I'm not sure we need big research teams to actually address some of these issues.
Well, I mean, the original internet started back in the 60s and didn't become popular and widely used until the 90s. So,
yeah,
absolutely.
Which is like thanks to the web, which essentially built a layer on top of the internet, and now we suddenly have a platform that we can use and build all kinds of applications on it. And maybe we see this a little bit with AR technologies, but the device fragmentation is very big at the moment. It's very difficult to create applications that run across multiple devices and multiple platforms. We're talking about smartphone, head-worn. We talked a lot about wearable displays, but also projective AR. Okay, so I think this was this was a discussion and an experience that I wanted to share with you. These are some of the people that work on a daily basis with these technologies. Maybe the testimonials were a little bit dark here, a little bit critical, but that's just what you get when you talk to experts that work a lot with these technologies. The future might be brighter, but it is just a phenomenon that happens to us because we talk a lot about these issues. So thank you for tuning in, and I'm looking forward to discussion with you in the discussion forums.